When we think about the internet, we usually picture this invisible cloud, right? This place where all our data just floats around. But the truth is, that cloud has a very real, very physical foundation. It's built on a massive global network of wires, cables, and super smart devices. So today, we're going to pull back that curtain and look at the actual hardware that makes it all work. I mean, it feels totally instant, doesn't it? You click, and boom, the page is there. But that single click kicks off this incredible physical journey for your data. We're going to follow that journey, right from your computer, through all the gear in your local network, and then out onto the huge digital highways of the internet. And it all starts with the roads themselves.
So first things first, data can't just teleport. It needs a path to travel on. In networking, we call this the transmission media. Honestly, the best way to think about it is as a system of roads and highways that connect everything. And just like real roads, they come in all different shapes and sizes, each one built for a specific kind of job.
Okay, so this one, you've definitely seen this before. This is the standard Ethernet cable, technically called a twisted pair cable, and it's the workhorse from most local networks. It's made of these pairs of copper wires that are twisted together, and that little twist, it's actually a super clever engineering trick to cancel out electronic noise and interference from other cables or even the lights in your room.
Next up, we have coaxial cable. You'll probably recognize this as the one that plugs into your cable box or your internet modem. At its heart, it has a single, solid copper core. That design lets it carry way more information, about 80 times more bandwidth than those twisted pair wires. It's kind of like the old, reliable interstate highway system. It's been around for a while, but it still does a heck of a job.
And that brings us to the true superhighway of the modern internet, fiber-optic cable. This is a total game changer. Instead of pushing electrical signals through copper wire, fiber optics send pulses of light through a tiny, hair-thin core made of glass. This is what makes things like 4K streaming and cloud computing even possible. It's just incredibly fast, it can carry mind-boggling amounts of data, and because it uses light, it's completely immune to the kind of electrical interference that can mess with copper cables. And just to really put that into perspective for you, a single fiber optic cable can have up to 26,000 times the bandwidth of a standard twisted pair cable. No, that's not a typo. It's an absolutely insane leap in capacity. It really is the difference between a little country back road and a futuristic bullet train. This is the tech that our high-speed, data-hungry world is built on.
So the big takeaway here is that each cable is a different tool for a different job. Twisted pair is the go-to for connecting your computer at your desk. Coaxial is that reliable pipeline that brings high-speed internet into our homes. And fiber optic, that's the global powerhouse, the internet backbone connecting entire cities and continents at the speed of light.
Of course, not all our data travels down a physical road, right? Sometimes the pathway is just the air itself. So let's talk for a second about going wireless. Wireless is pretty straightforward. It just uses radio waves to carry signals between your devices. The two you use constantly are Wi-Fi and Bluetooth, and the main difference between them is really just range. Bluetooth is designed for your personal space, your little bubble, connecting your headphones to your phone, usually within about 30 feet. Wi-Fi, on the other hand, has a much bigger reach, up to 300 feet, designed to cover your whole house or office with a network connection. You're basically trading the perfect stability of a wire for the awesome freedom to move around. Okay, so we have the roads, both wired and wireless, but roads are chaos without rules, right? Without traffic lights and road signs. So how does the data know where it's supposed to go? Well, that's where the network's traffic cops come in. These are the devices that actually manage and direct all that information zipping around. Ah, yes, the classic question. Hub, switch, router. They kind of look the same, they all have a bunch of ports, but they operate on completely different levels of intelligence. So let's break it down and go from the dumbest device to the smartest. Let's start at the bottom with the hub. A hub is the most basic, least intelligent connector you can get. The best analogy for it is an old-timey town crier. When a piece of data comes into one of its ports, it has no idea where that data is supposed to go, so it just shouts it out to every single other port. Every device on the network gets the message, even if it was only meant for one of them. As you can imagine, that's incredibly inefficient. Now, a switch is way, way smarter. Think of a switch like a mail sorter at the post office, but just for your local network. It actually learns the unique physical address, it's called a MAC address, of every single device that's plugged into it. So when a packet of data comes in, the switch looks at the to address and sends it only to the one specific device it's meant for. This is a massive improvement. Just replacing an old hub with a switch can cut down on all that unnecessary network chatter by up to 99%. And finally, we get to the router.
the smartest of the three. If the switch is the local mail sorter, the router is the entire postal service. Its main job isn't just to direct traffic inside your network. Its job is to connect different networks together. Specifically, your home network to the giant global network of the internet. It uses logical IP addresses, which are kind of like mailing addresses for your devices, to figure out the best path to send your data across the world. Your router is literally your gateway to everything online.
And here you can really see that progression in intelligence, especially if you get a little technical. A hub is a simple Layer 1 device. It just passes along electrical signals. That's it. A switch is smarter, operating at Layer 2 to direct traffic locally using those physical MAC addresses. But the router is the brainiest, working at Layer 3 to connect entirely different networks using those logical IP addresses. Each step up is a huge leap in sophistication.
Now, before we put this all together, there's one more key player we have to mention: the firewall. Think of this as the security guard for your network. It stands at the gateway, usually as part of your router, and it inspects all the traffic coming in and going out. It's constantly checking to see if anything looks suspicious, and it'll block anything that violates the security rules. It's absolutely crucial.
Okay, so now that we've met all the hardware, the pathways, and the traffic cops, let's trace the full journey of that single click, from start to finish.
So you click a link. Your computer immediately turns that request into little packets of data. That data then travels from your device over a pathway, either down an Ethernet cable or through the air via Wi-Fi, to a switch. The switch intelligently looks at the data and directs it straight to your router. And then the router, acting as the gateway, sends those packets out of your local network and on to the massive superhighways of the internet, where it travels to its final destination. All in the blink of an eye.
So when you really step back and look at it, what feels so seamless and invisible is actually this highly coordinated dance between all these very real, very physical pieces of hardware. Every single cable, every switch, every router is playing its own crucial part to make our digital world a reality. And that brings me to a final thought. Our entire modern world runs on this hardware, but our demand for data, for streaming, for cloud computing, for AI is growing exponentially. It's just exploding. So you have to wonder, what does the next generation of this hardware even look like? What will the internet's superhighways be made of tomorrow?